What's it time for, Grace?
It's time for Maths with Mr. Thomas.
Oh yeah. Here we are with chapter 15, lesson number 3, looking at logarithms, converting between log form and exponential form. So, logarithms are something that we have come across already in this course, a way back in chapter 3. To introduce them, let's think about exponentials though. Imagine if I asked you to work out the index in each of these exponentials. So I'm giving you 4 to the power of x equals 64. So what value would x be? Is it 4 squared, 4 cubed, 4 to the power of 4, and so on? What number would go there? 3 to the power of m equals 243. Again, see if you can work out what m would be. Or if it was 5 to the power of a equals 30, what value would a be? Really, for each of these, it's going to be time consuming. Really, you've got to think 4 to the power of what gives us 64, which, yeah, that's maybe a quicker one. You know, it's going to be 4 cubed, so x is just going to be 3. So either you can work it out by taking a wee bit of time and then multiplying 3 by itself so many times to see what gives you 243, but sometimes you might get something like this with 5 to the power of a equals 30. And for that, well, you know 5 squared, 5 times 5 is 25, 5 cubed, 5 to the power of 3 is going to be 125, so you know the number then that a is going to represent is going to be between 2 and 3. So we're going to get a decimal in there. So we could also use a bit of trial and error to narrow down the answer, maybe to a few decimal places. However, what we're going to do in this lesson is we're going to find a way of working out what this index would be. And to do that, we're going to use the inverse of exponentials, which is, say it with me, logs. Woo! Or logarithms. So the inverse of an exponential function is called a logarithmic function. So if f of x equals 2 to the power of x, then its inverse, f to the negative 1 of x, is going to equal log base 2 of x. As I said, this is something we have come across. This is what we looked at in chapter 3 when we were looking at functions. So logarithmic functions are of the form y equals log base a of x. And since they're the inverse of exponentials, we can easily graph them. Remember, to graph an inverse function, you reflect it in the line y equals x, this grey dotted line here. So if we had this exponential function, its inverse would be this red line here. And you know your exponential function always passes through the point 0, 1 and then 1a. So the log graph is going to pass through 1, 0 and then a 1. In this case, I've got y equals 2 to the power of x. Its inverse will be log base 2x, so that will pass through 1, 0 and 2, 1. If you had log base 3 of x, that would pass through 1, 0 and 3, 1. Log base 5 of x would pass through 1, 0 and 5, 1. I'm sure you get the idea. This line here, this y-axis, if that just continued right the way down and this red line continued down as well, well, the y-axis is known as an asymptote. Woo! And that means that the graph is going to get closer and closer to the y-axis, closer and closer to this asymptote, as y tends towards negative infinity, so it keeps going down and down and down and down and down, but they're never going to come into contact. Let's move on now then to something new with logs. So, if we have 2 to the power of x equals 32, well, that's known as exponential form. And its inverse is going to be log base 232 equals x, which is logarithmic form. What we need to be able to do easily is to switch between exponential form and log form. And to do that, well, you could think about a couple of ways. I suppose the correct mathematical way of doing it is to do the same thing at both sides. So here you could take logs of both sides. So let's start with this example then. If we have 2 to the power of 5 equals 32, well, what we can do, we know already if we do the same thing to both sides of an equation, well, the sides will remain equal. So, because here we've got our base and our index, we've got the base of 2, well, we could take the log base 2 of both sides. So doing that, you'd have log base 2, 2 to the power of 5, equals log base 2 of 32. Now, because we've got log base 2 and we've got an exponential base 2, well, remember, log base 2 and exponential base 2 are the inverse of one another. So really they will cancel out. And if log base 2 and exponential base 2 cancel, it'll leave us just with 5. So we'll have 5 equals log base 2 of 32. We can then rewrite that if we want. You don't have to, but if you put that back to front, you'd have log base 2 32 equals 5. So we can switch between exponential form and log form. There is another way I like to do it though. I'm calling it base bottom top, and that is a quick way of changing between exponential form and log form. So I'm going to show you this with base bottom top. So base bottom top, here's what you do. A quick way of changing from exponential form to log form and vice versa. So if you were given, say 2 to the power of 5 equals 32, and you have to write that in log form. First thing you want to do is you want to start with the base. The base is the bit that's below the index. So here we've got our index of 5, so our base is going to be 2. So that's where we start. What we then do is we draw a line across to the other side just at the bottom. So we're starting with our base of 2, and because we've got our base of 2, and this is exponential form, if we write it in log form, we're going to have log base 2. Draw a line then from that base across to the other side, across the equal sign, and we've got 32. So we're going to have log base 2, 32. And what's that going to equal? Well, that will equal, after that, draw a line back across at the top. So we've got our base, draw a line at the bottom, then draw a line at the top, and the only number remaining is 5. So that will equal 5. We can also work back the way as well. If we were given this log form and we want to change it back into exponential form, well, again, start with the base. The way you read this is log base 2. So we know our base is 2. So we have 2 to the power of, and then draw a line at the bottom across to the other side. Across there is the number 5. So we'll have 2 to the power of 5. And that will equal, draw a line back across at the top, and you have 32. So if we rewrote that in exponential form, you can see it there, but base, bottom, top, we'd have 2 to the power of 5, and that would equal 32. There are a couple of special cases though with this, with log form, when you switch between log form and exponential form, and these are things that you are expected to know. So if you have log base a and then an exponential base a, or if we have an exponential base a and then a log base a, well, you know again, one is the inverse of the other. Log base a and exponential base a, they are the inverse, so they will cancel. And if they cancel, it will leave us just with x. So always have a look out for that. If we've got log base a and exponential base a, or an exponential base a and then log base a, again, they'll cancel. So we'll be left with x. Other things, if we have log base a of a, well, really, if you rewrite that, what you're thinking is a to the power of what gives you a. Imagine it with numbers. 3 to the power of what equals 3. Well, you know it's not 3 squared, you know it's not 3 cubed, you know it's just going to be 3 to the power of 1. So here, a to the power of what is a? Well, it's just a to the power of 1. So if you ever see a log base a of a, so if you have log base 7 of 7, or log base 12 of 12, or log base 3 of 3, well, you know that's just going to be 1, because if you rewrite it, it's just going to be a to the power of what equals a, and it's just 1. Another thing, if we have a to the power of something is 1, well, what number will that be? A to the power of what will always give us 1. What's that going to be? Help us out. Good, it's going to be 0. Yeah, anything to the power of 0 is going to be 1. So if you have log any base, 1, well, that's always going to equal 0. Let's try some examples then of switching between log form and exponential form. So here we've got our exponential form. We've got our 2 to the power of 3 equals 8. What we need to do is switch that into logarithmic form. So again, I'm going to use base bottom top to think about this. So start with the base. So find the part that's with the index. That's here. So our base is going to be 2. So writing this in log form, I'm going to have log base 2. After that, base bottom top, draw a line in the bottom across to the other side, and I've got an 8, so it's log base 2, whoops, it's going to be log base 2 of 8, and that will equal, draw a line then back at the top, the only number left there is 3, so log base 2 of 8 equals 3. Do the same thing for the next one. If we have this exponential form, write it in log form. Find the base is the part with the index, which is going to be 4, so we're going to have our log base 4. So we've got log base 4. After that, if you draw a line at the bottom, so base bottom top, start with the base, draw a line at the bottom to the other side, and we have 64. So it's going to be log base 4, 64. And that will equal, After that, draw a line at the top. And at the top, we've got 3. That's the only number left, so that is what it's going to equal. Next one, 7 to the power of 2 equals 49. Rewriting this in log form, start with the base, look for the part with the index. There's our base there, that's 7. So we're going to have log base 7. After that, draw a line at the bottom to the other side, and we've got 49. So log base 7, 49, equals, and if you draw a line at the top, across at the top, we've got 2. So that will equal 2. Let's try the next couple. So 1/9 equals 3 to the power of negative 2. Again, if you think base, bottom, top. Where's the base? Well, the base is the part with the index. That's just here. So we've got our 3. So we're going to have log base 3. After that, base, bottom, top. So base, bottom, draw a line at the bottom to the other side. And we have 1/9. So it'll be log base 3, 1/9. Equals, draw a line then at the top. So from 1/9, you're coming back over. And we've got negative 2 here, so that will equal negative 2. Go to the other question. We've got 27 to the power of negative 1/3 equals 1/3. So writing that in logarithmic form, start with the base. You know that's 27 because it's 27 to the power of something. So we're going to have log base 27. After that, base, bottom, top, so draw a line at the bottom to the other side, and we have 1/3. So log base 27 1/3 equals, and if you draw a line at the top, we're left with negative 1/3. So we know then that that will equal negative 1/3. So base, bottom, top, changing between log form and exponential form. That is what you would do. Let's try it the other way. So for these ones, I'm going to give you them in log form. Let's rewrite them as exponential statements. So to do that again, you need to find your base. So here we've got 5 equals log base 2 of 32. So our base is going to be 2. So we know then that we're going to have 2 as our base. So it's going to be 2 to the power of something if we write it in exponential form. So draw a line at the bottom to the other side. So it'll be 2 to the power of 5. And that will equal, if you draw a line at the top, move over, the only number you're left with is 32. So it'll be it'll be 2 to the power of 5 equals 32. Next one, if we have log base 5 of 125 equals 3, again start with the base. Which number's the base, Sandy? Good, it's going to be 5. So we're going to have a 5 to the power of base, bottom, top. There's the base, draw a line at the bottom to the other side, and that gives us 3. So it'll be 5 to the power of 3 equals, and then draw a line at the top. And we were left with 125. So 5 to the power of 3 equals 125. Next one, log base 2 of 1 over 64 equals negative 6. Do the same thing again. What number is the base? What's it going to be? Good, it's going to be 2. We've got log base 2. If we're writing it in exponential form, it'll be 2 to the power of. Draw a line at the bottom to the other side. So it's negative 6. So 2 to the power of negative 6 equals, and draw a line at the top. We have 1 over 64. So we will have 1 over 64. Next one, log base an equals b. So here again, we need to find the base. If to write it in exponential form, what's the base, Aaron? Good, it's going to be a. So we're starting with a. Draw a line at the bottom, so base, bottom, top. Line at the bottom to the other side gives us b, so it'll be a to the power of b. And that will equal, draw a line at the top. That will give us n. Good, well done. Next one, if we have log base 4 of 1 equals 0, rewriting that in exponential form, well, first of all, find the base, bottom, top. So there is the base. So we've got our 4 to the power of, draw a line at the bottom, that gives us 0, so 4 to the power of 0, and that will equal, draw your line in at the top, the only number left, if we go across to the other side, will be 1. So 4 to the power of 0 equals 1. Let's try some more. Example 3 for each of the following. Write in exponential form and hence find the value of x. So for this one, log base x of 25 equals 2. So this is going to be difficult to work out unless it's in exponential form because we need to think about what this means. So rewriting it in exponential form, you want to find the base, to use base, bottom, top. So the base is going to be x. So we're going to have x to the power of base, bottom, draw a line to the bottom, we get 2. So it'll be x to the power of 2 equals 25, if you draw that line in at the top as well. So base, bottom, top. After that, x to the power of 2 equals 25. From there, you should be able to work that out. X squared is 25, so obviously x is just going to be 5. Next one, log base 4 of x equals 3. Do the same thing again, rewriting it in exponential form. It's log base 4, so base bottom top. Start with the base, draw a line across the bottom to the other side. So we're going to have 4 to the power of 3 equals, draw a line at the top. All we're left with is x. So base bottom top, we've got 4 to the power of 3 equals x. After that, to work out x, well, we know it's just 4 to the power of 3, so it's 4 cubed, 4 times 4 times 4, and that gives us 64. So that is the value of x. Next one, log base 6 of x equals negative 2. Do the same thing again, rewriting it in exponential form. Mary Lou, off you go. What would you have? Good, we're going to have 6 to the power of negative 2. You're perfectly right. So base bottom top, start with the base, it's a 6. Base bottom top, so bottom, draw a line in there, it's negative 2, so it's 6 to the power of negative 2, and that will equal, if you draw your line at the top, all we're left with is x. So it'll be 6 to the power of negative 2 equals x. Going to rewrite this back to front, so x equals 6 to the power of negative 2. How do you work out 6 to the power of negative 2? Good, you rewrite that with a positive index, so that will be 1 over 6 squared. And we know 6 squared is going to be 36, so we just get 1 over 36. And that will be our answer. Next one, so example 4, evaluate each of the following. So we've got A, B, C, and then some more examples on the other pages. But starting off with log base 9 of 81, we want to evaluate that and find what that is equal to. To do that, I always say it's best just to set that equal to something. So I'm just going to set that equal to x. So really what I want to do is I want to find out what that's equal to. So I'm just going to call what it's equal to just now x. So x equals log base 9 of 81. From there then, well, to work it out, it's difficult to work out in log form, but it's easy to work out in exponential form. So rewrite it as an exponential. So to do that, base bottom top, start with the base. Well, it's log base 9. Bottom, draw a line at the bottom across to the other side. That's x. And then draw a line in at the top. And we get 81. So rewriting it in exponential form, we'd have 9 to the power of x equals 81. And from there, well, 9 to the power of what gives you 81? That makes it easier to work out. So we know what it's going to be in exponential form. We know that 9 squared is 81, so x is just going to equal 2. Make sure, though, if you're asked to evaluate this, don't finish off by saying x equals 2. We're not given x, we're not asked to work out x. We just have to work out what this is equal to. So we're going to finish off by saying then that log base 9 of 81 equals 2. Next one, log base 2 of 64. So for this one, again, to evaluate that, I'm going to set that equal to something. Again, I'm just going to let it equal x. So x equals log base 2 of 64. Again, it's difficult to work out as a logarithmic function, so rewrite it as an exponential function. So base bottom top, start with the base, draw a line at the bottom to the other side, draw a line at the top to the other side. So in exponential form, we'd have 2 to the power of x equals 64. From there, we need to work out what the value of x is. Well, to do that, you should be able just to work that out. It may take a few seconds, but think 2 times 2 is 4, times 2 is 8, times 2 is 16, and so on. Work your way up, and you will get x to be equal to 6. 2 to the power of 6 equals 64. Therefore, again, if you're asked to evaluate that, don't finish off by saying x equals 6. We're not given x. We're not asked to work out that. We're asked to work out what this is equal to. So you can finish off by saying log base 264 equals 6. Example C. So log base 3 of 1/9. Again, find out what that is equal to. To do that, I'm just going to set that equal to x. So say x equals log base 3 of 1/9. Again, it's hard to work out when it's in log form, so rewrite it as an exponential. So think base bottom top. Well, I'm going to have at the base of 3. Draw a line at the bottom across to the other side, and I get x. And draw a line at the top across to the other side, and I get 1/9. So base bottom top, if you rewrite this as an exponential, we'll have 3 to the power of x, and that will equal 1/9. Now to do this, again, it's going to be a bit trickier, even if it's in exponential form. So you really need to know your surds and indices chapter really well, which is why I made that lesson 1 way back at the start. For this, you need to know your indices, rules, and so on, inside out. So here we've got 3 to the power of x equals 1/9. Well, if you think about it, ignore the 1 over. Imagine if you had 3 to the power of x equals 9. Well, we know that's easy enough to work out. It's just going to be 3 squared. 3 squared is 9. But because it's 1 over 9, well, really, we're moving the 9 from the top to the bottom. So the index isn't going to be 2. It's going to be -2. So x is going to equal -2. Again, we're asked to work out the value of log base 3 of 1/9. We set that equal to x. We found that was equal to -2. So we can finish then by saying that log base 3 of 1/9 equals -2. Let's try some more examples. Should get a little bit trickier. So d, log base 8 of 2. So for this one, again, to evaluate that, just set it equal to something. So I'm going to have x equals log base 8 of 2. For this then, I need to rewrite it as an exponential form. That's going to make it easier to work out. So doing that, base, bottom, top, start with the base. Whoops, draw a line across the bottom to the other side, and then draw a line at the top to the other side. So I'm going to have 8, that I wrote all over, to the power of x equals 2. So rewrite it as an exponential. From there, 8 to the power of what equals 2? Well, for this, again, you need to know indices really well. 8 to the power of what is 2? Well, the number's not getting bigger. It's not going to be 8 squared or 8 cubed. It's going to be a smaller number. So we know we're going to take a root of 8. Think about which root it would be. Is it going to be the square root? Well, it's not the square root of 8. That's not going to be 2. Is it going to be the cube root? Well, yeah, it would be. If we multiply 2 by itself 3 times, that will give us 8. So we know this, because it's going down the way and we've got a smaller number, it's going to be a fractional index, and it's the cube root of 8 that will give us 2. And the cube root of 8, if you write that as a fractional index, it's going to be 1/3. So therefore, you know that log base 8 of 2 equals 1/3. Again, if you're unsure of this, you may wish to go back to that very first lesson reviewing the indices. Next one, log base 81 of 9. For this one, again, to evaluate it, just set it equal to something. So say x equals log base 81 of 9. Difficult to work out as a log, so rewrite it as an exponential. So base, bottom, top, start with our base. Well, it's log base 81. Draw a line at the bottom across to the other side, and we've got x. Draw a line at the top, back across, and we've got 9. So as an exponential, we've got 81 to the power of x equals 9. For that, again, the number's getting smaller. It's not going to be 81 squared, 81 cubed, 81 to the power of 4. Its number's a lot smaller. So we know we're going to have a fractional index. Think, what fraction would you have there? 81 to the power of what gives you 9? Well, to do that, you want to think about roots. So is it square root, cube root, and so on? What you should be able to work out is that the square root of 81 is 9. And the square root, if you write it as a fractional index, is the power of 1/2. So we know then it's 81 to the power of 1/2, and that would equal 9. Therefore, we set that equal to x. We found x was 1/2, so we know then that log base 81 of 9 equals 1/2. And that's your answer. Woo! F. So, log base 25 of 1/5. To work that out, again, you want to set that equal to something. So again, I'm just using x. So say x equals log base 25 of 1/5. Difficult to work out as a logarithmic function, so rewrite it as an exponential. So base, bottom, top, start with our base. Well, it's log base 25. Draw a line at the bottom across to the other side. So it'll be 25 to the power of x as an exponential. And that will equal, draw a line at the top, and we've got 1/5. So 25 to the power of x equals 1/5. Again, you need to think, right, well, 25 to the power of what is 1/5? Obviously, the number's getting smaller, so we're going to have a fractional index. So for that, we're thinking about roots. Ignore the 1 over. So if you just had 5, 25 to the power of what is 5? Well, we know that's going to be the square root. So we're going to have to the power of 1/2. But because it's going to be 1 over 5, we know that half will change from a positive index to a negative. So it'll be 25 to the power of -1/2. Therefore, log base 25 of 1/5 is going to be equal to -1/2. Last one, so g, log base 16 of 1/2. I need to evaluate that and find out what it is equal to. So to do that, set x equal to log base 16 of 1/2. Whole point in doing that is it lets you rewrite it as an exponential. It's far easier to work out. So base bottom top, the base, it's log base 16. So I'm going to have 16 to the power of, draw a line at the bottom, and I've got x, and then draw a line at the top, and I've got 1/2. So 16 to the power of x equals 1/2. From there then, I need to work out what x is going to be. Obviously, the number is smaller than 16, so I know I'm not going to have 16 squared or 16 cubed. I'm going to have a fractional index. For this, whenever it's 1 over something, ignore the 1 over and just imagine it was 16 to the power of x equals 2. Well, for that, what you need to think is roots. So is it the square root, the cube root, the fourth root, the fifth root, and so on? How do you go from 16 to 2? What you should be able to do is to work out that it's going to be the fourth root. If you multiply 2 by itself 4 times, you'll get 16. So it'll be 16 to the power of a quarter. This will give you 2. However, it's not 2 we've got, it's 1 over. So that quarter will change from a positive a quarter to a negative. So I know x would equal negative 1/4. From there then, I've got log base 16 of 1/2. That was equal to x. X is equal to this. So you can finish off by saying log base 16 of 1/2 equals negative 1/4. That's it for logarithms. Try these questions and give me a shout if you are unsure. But really, you need to be an expert with changing between log form and exponential form and then solving the various problems that involves. Good luck. Bye. Woo!